This is the proof that we are going to have better approximation. Let's try with another example. For example, suppose that we have 6.34 nanoseconds minus 2 milliseconds. Let's see. Seconds and seconds maybe, but we have some prefix. The first thing, get rid of prefix. Times 10 to the negative 9 seconds minus 2 times 10 to the negative 3 seconds. Scientific notation, yes. Scientific notation, yes. So let's try to see the difference. Minus 9 minus 3. And this is going to give me minus 9 plus 3 equal minus 6. And 6 is bigger than 3. Again, like the previous example, the number with the biggest magnitude order will be approximately the answer. Now, which one has a biggest magnitude order? This one. So the answer is going to be approximately minus 2 times 10 to the minus 3 seconds, or minus 2 milliseconds. So the unit milliseconds is 6 magnitude order, a million of times bigger than the nanoseconds. For this reason, we keep that expression like a negative. One more example. What happens when it's not possible, it's so simple to see the units? And let me use an extra piece of paper. Let's try something like this. 6.3 times 10 to the 4 millimeters per second times 3 times 10 to the minus 1 second plus 7.3 times 10 to the 3 seconds squared and 7.3 meters per second squared. Let's see. Apparently we cannot see, it's not so simple to see. So we have to solve all this problem until we have the most simple expression, scientific notation, and the basic units, and do the same for the other side. The other way, we cannot cross this plus. Let's simplify. Any prefix, milli. So 6.3 times 10 to the 4 milli times 10 to the negative 3 meters per second. And this one. For the other side, we have 7.3 a scientific notation, the basic units, scientific notation, times 10 to the 0. So we can multiply 7.3 times 7.3. It's going to be 7.3 squared, but we can keep like that. The only power of 10 is 10 to the 3. And we have seconds squared times meters per second squared. If you remember, integers, we divide by 1, and we can apply numerator times numerator, denominator times denominator. In this one, I still need to simplify this expression. 6.3 multiplication with the same base, we add 4 plus minus 3 is 1. And we have meters per second. .3 squared is going to give me 53.29 times 10 to the third power. Here we have seconds squared meter divided 1 times second square. Let's keep simplifying. Scientific notation, basic units, I can go out. Scientific notation, basic units, I can multiply. So numbers with units and units with units. Numbers with numbers, powers of 10 with powers of 10, 1 plus minus 1, and units with units, meters per second times seconds. Remember that we express this one like to be an integer. In this is not yet scientific notation, I can move my decimal point. 5.329 times 10 to the left is going to be bigger, 4. So I have the same base, it's going to be 1, but only for educative purpose. Remember that we subtract 2 minus 2 meters. I am subtracting the power of the denominator. So 6.3 times 3 is going to be 18.9 times 10. Positive times negative, negative 1 minus 1, 0. And we have here meter seconds, it's 1 minus 1. Or we can cancel from here. Plus 4.329 times 10 to the 4th power. 2 minus 2, seconds to the 0 is going to be 1, and we have the only unit that survived is meter. Here we have not scientific notation, it's powers of 10. I'm going to move my decimal point. Meters times seconds to the 0, that's going to be 1. We hide those ones, and finally we have in scientific notation both expressions, and we can see what is the unit that survived, meters and meters. Maybe. So the rule says whenever we have in scientific notation both expressions, pay attention to the magnitude orders. It's 1 minus 4 to make the difference in absolute value. Minus 3 equal 3. This is exactly in the limits. So the rule says if the difference is smaller or equal than 3, we are in that example, we can choose the magnitude order of 1. I'm going to solve keeping this magnitude order. 1.89 times 10 to the 1 meters. And we need to move the decimal point of the other one until we have 4. So we are 4, 3, 2, 1. Now we solve the numbers with numbers, and we have the same units with the power of 10 included. So this is going to be 5,330.89 times 10 to the 1 meters. You see? We can keep this expression like this, or we can play with that. 1, 2, 3. Exactly like that, we can express the quantity like to be in kilometers, or if you want to express in scientific notation, any case is correct. What happens if you choose to keep this, the 4? I'm going to try the problem solving for the 4. So I'm going to keep 5.329 times 10 to the 4 power and move my decimal point from 1 to the left. So it's going to be, it was here 1, 2, 1, 2, 3, 4. I can make the groups with the numbers 0.00189 plus 5.329 times 10 to the 4 meters. This is the same like to express 5.389 times 10 to the 4 meters. See this, we have exactly the same answer. After that, you can play again with your decimal point to express like 53.389 times 10 to the 3 meters. We have one prefix that we can use. Or you can use different expressions for that. Any case, the answers could be any one of these. Now, let's try another example. What happens if we have something like this? Suppose that we have 0.0005339 times 10 to the 4 milliseconds per ampere and to the second power, and we try to add this to 2.12 times 10 to the 4 seconds square ampere. Let's see, we are not sure, so first try to simplify. Scientific notation is the most simple. I'm going to start to use the 4 here and my decimal point. So 4, 3, 2, 1, 0. 5.39 times 10 to the 0. Prefix, I have milli. Milli means times 10 to the negative 3, and I have seconds, ampere here, and that is square. I'm still not sure if I have the same units, so until I simplify all this. Remember, we cannot cross addition and subtraction until we have the most simple expression and we are sure that we have the same units. This is basically already waiting for the simplification of this part. This is 5.39 times 10 to the negative 3. We have seconds, ampere, but still we have that power. Okay, remember that this power affects to the number, to the power of 10, and to the units. So it's going to be 5.39 second power, 10 to the negative 3 to the second power, and seconds ampere to the second power. So 5.39 second power is 29.0521. Powers on powers multiply. 3 times 2, 6. And also the power that we have here, seconds square, amperes square, both, plus 2.12 times 10 to the 4th seconds square ampere. From here that we have already the units, we can identify. We have in the left side second square per ampere square, and we have second square per ampere. We cannot do more than that. Probably simplify this one a little bit more, but that will be all. So we have different units, we cannot add this. Maybe the only thing left is expressed in this way. Minus 5 seconds square ampere square, 2.12 times 10 to the 4th seconds square ampere. That will be the final answer. We cannot add because we have an orange and we have an apple. So pay attention in that as soon you are doing your problems with addition and subtraction. Fortunately in the class we are not going to be solving many of them.